Okay, the first page is what we've already learned in day one and day two on radicals. I'm just gonna just review these with you. So basically 64 is made up of 8 times 8, and for every 2, I can take 1 out. So I'm just quickly reviewing this that we already spent a couple of days on. 18 is 2 times 3 times 3. For every 2, I can take 1 out, but the 2 has to stay inside. And then this one, um, the square root of 162 is made up of 2 and 81, and this is made up of 2 and 2 nines, and you can stop right there because we have 2 nines, so it's 9 root 2. The square root of 72 is made up of 8 and 9, and 8 is made up of 2 times 2 times 2, and 9 is made up of 3 times 3. But don't forget the negative sign, and I can circle a 2 and a 3, so the 6 can come out because a 2 and a 3, and then the 2 stays inside. Again, this is all review. We just did this. How do you do fractions? You have to break it up into the square root of 1 over the square root of 9. Whenever you're given a fraction, you break it up into 2 individual problems. The square root of 1 is 1, and the square root of 9 is 3, so your final answer is 1/3. This one, I would simplify this to 1 over 3. That's what I would do first. I would break it up into the square root of 1 over the square root of 3. And everybody knows that the square root of 1 is 1 over the root 3. There's a rule in math that says you can never leave a radical in the denominator. So I need to multiply the top and the bottom by the square root of 3 so I can get rid of the square root of 3 on the bottom. So the top is going to be the square root of 3. On the bottom is you have 2 underneath. I can take 1 out. So that's my final answer, square root of 3 over 3. And the same thing for this one. If you're given a large fraction radical, break it up into 2. Again, you can't have a root in the denominator, so you multiply the top and the bottom by root 2. I meant root 5, This is the square root of 10 over, for every 2 that you have underneath, I can take 1 out. You cannot simplify the 5 and the 10 because the 10 is underneath the radical. Okay, the next one, instead of doing square roots, we're going to do cube roots. Again, split it up. The cube root of 2 over the cube root of 9. I have 2 3's underneath. That's only 2. I need 1 more 3. So I need to multiply the top and the bottom by the cube root of 3. I don't want to multiply by the cube root of 9. I need 3 of something. So that's 1, 2, and this extra one would give me 3, which would give me 3 down in the denominator. And the top is just going to be the cube root of 6. You always look to see how many you have, how many you need, and what you have to multiply by. For the next one, I'll put it over here. It's the cube root of 2 over the cube root of 3. And I need to multiply the top and the bottom by the cube root of what? Okay, let's look. We need 3 of something. We only have 1 3. But we need 3 of something, but we only have 1 3. I need to multiply the top and the bottom by 9. That gives me 2 more 3's, which would give me a 3 as a flat answer. And the top would just be the cube root of 18. It's a process of elimination, how many you have and how many you need. We might as well do the 4th root. Break it up, remember, into 2 separate radicals. If you see this on the ACTs, you're going to see a gigantic fraction with a radical, and you're going to say to yourself, that's right, Miss Cho said to break it up into 2 separate radicals. The 4th root of 1 is just 1. So now you have the 4th root of 25. This tells you how many things you need. I need 4 of something. Well, 25 is made up of 5 times 5. So I have 2 5's. How many more 5's do I need? Don't I need 2 more? So don't I have to multiply it by the 4th root of 25? My final answer is the 4th root of 25 on the top over just 5 on the bottom. So I think I did plenty of fractions. Okay, so basically, you need to turn it off. You need to turn it off and just do the first worksheet on radicals. So I misspoke, but the radical worksheet 1, turn this off after the first 2 pages and start working on radical worksheet 1. Okay, I'm back. And this is going to be the radical worksheet 2 video. And this is only 1 page long. So, or 1 template long. So I could do some extra ones, but I have 5 problems. So radical worksheet 2 compared to radical worksheet 1, the only difference is you have variables for your next worksheet. So you're going to do the same thing that you did on that first worksheet. You're going to take the 12 and break it up into a 2, a 2, and a 3. We have 3 A's and we have 4 B's. And we're going to do the exact same concept. We are going to be looking for the square root, or we're going to be looking for 2's of something. So you're going to do the same concept like we did on the first worksheet, except we have variables also. I'm looking for 2's, so or 2's of something, so I can take a 2 out. The 3 has to stay inside. I can take an A out, but one of the A's has to stay inside. We have a lingering 3 and a lingering A. We have 2 groups of B's, so that'll be B squared on the outside, and there's no B's left on the inside because there is an even amount. So this is what we're doing on the second worksheet for this test. Okay, let's do this again. 48 is made up of 6 times 8, which is 2 times 3 and 2 times 2 times 2. So we have that. We are looking for the square root, so we're looking for those 2 2's and those 2, so I can take out a 4 because I have 2 2's, but I still have a 3 left inside. A lot of you don't have to write out 5 U's. A lot of you know that you're going to circle. Well, I'll write them out. A lot of you can visualize circling 2 groups of them with 1 U left inside. See if you can visualize taking out how many groups, how many pairs are there for Z to the 7th? Isn't there 3 pairs with 1 lingering Z? And if you don't believe me, let's show you that there are 3 pairs. Here are 7 Z's. Here's 1, here's 1, and here's 1, which makes Z to the 3rd with a lingering Z. Okay, now let's do one more. Let's do one more. Let's extend the page. Before we get to fractions, let's just do one more. Let's do the cube root of 72, A to the 5th, B to the 6th, C to the 8th. Let's just do one more of these. We're not looking for 2's, we're looking for 3's of something. 78 is made up of 8 times 9, which is made up of a 2, a 2, and a 2, and a 3, and a 3. Okay, so we're looking for 3's. So I can take out a 2, but remember to write a cube root home, so you can put the 3 inside of that home. I call it a home because there's a square root home and a cube root home and a fourth root home. How many groups of 3's are there for A's? There's only one group of, there's only one of them, but there's 2 lingering on the inside. And I'm going to show you really quick. I can circle 3 of them, and for every 3 I can take one out with 2 left. There's going to be 2 groups of B's. There's no B's left on the inside. And then the C's, I might as well show you for the C's that there are some lingering. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to circle groups of 3, groups of 3. So I'm going to take out C to the 2nd, and I'm going to leave 2 of them on the inside. Final answer. So I thought I'd show you a cube root one, because I showed you some square root ones up here. Okay, now let's do a fraction. Whenever you see a fraction on the ACT or in the homework, you have to break it up into the numerator and the denominator. We're talking about the square root, so you have to get rid of the 2 and you have to get rid of the x. So I need to multiply the top and the bottom by, I only have one 2, I need another 2. I only have one x, so I need another x. So I have to multiply the top and the bottom by that. So that means I have 2 2's, and for every 2 2's, take one out. I have 2 x's, for every 2 x's, take one out. I no longer have a radical in the denominator, and the top is just going to be the square root of 6x. Final answer. Okay, the next one, again, you have to break it up into 2 different radicals. Okay, you're looking for pairs of stuff because it's a square root. So this is made up of a 2 2's and a 3. And you know you need pairs of stuff. So don't we already have 2 2's and don't we already have 2 c's? Did everybody see that? We have 2 2's and we have 2 c's, but we only have 1 3. We need one more 3. So that's the only thing that we have to put over here, because now we can take out a 2 because we have enough of them. See right here, we have 2 2's. We have 2 c's, so we can take out a c, and we can also take out a 3 now because we added an extra there, which will make the 2 6. The top is, we have 2 a's to take out and 3 b's to take out, but we still have a 3 left on the inside for this problem. Final answer. Okay, let's do a couple more and we're done with these notes. Guess we only have one more to go. It's the cube root of 3x over the cube root of 2y to the second. We need to multiply the top and the bottom by the cube root of something, and we have to figure out what that cube root is. So let's look. We need 3's of stuff. We only have 1 2. How many more 2's do we need? Don't we need 2 more of them to make 3? We have 2 y's. How many more y's do we need? Don't we only need 1 y so that there'd be 3? So we only have 1 2. We need 2 2's. So doesn't 2 2's make 4? We have 2 y's. We only need 1 more y. So we need to multiply the top and the bottom by 4y. The 4 are going to make the 2 2's, and the y is going to make the third y. So for every 3 2's we circle, we can take out, and for every 3 y's we circle, we can take 1 y out. What do we have left up above? We have an x and a y. We don't have enough of those. You need 3. And the 3 and the 4, we don't have enough of those, which is the square root of 12, or cube root of 12, I mean. Okay, now, when you get to this page, you can stop the video and start working on the second day of radicals. The second day of radicals. Okay, I'm giving you 2 days to work on 5.4 complex numbers. This is something you've never seen before. It's called a complex number. And this is going to look really weird because you've never seen it before. But, so the square root of 4 is equal to 2, correct? If you try to plug in the square root of a negative 4 into your calculator, it's going to say error. You cannot do the square root of a negative 4. So a mathematician invented imaginary numbers because we cannot do the square root of a negative 4. So this is going to look really weird and you have to watch very carefully, but they came up with the imaginary number I, which is right here. Imaginary number I is the same thing as the square root of a negative 1. And I'm going to show you how they got it. This is what they did. They brought the negative sign out of the radical, and that turns into the letter I, and then you're left with the square root of 1 because you took the negative sign out, and it turned into I, and the square root of 1 is 1, which is equal to 1I. And that's how they got that the square root of a negative 1 is the same thing as I to the first power. The square root of a negative 1 is equal to I, and this is also equal to I, so this is equal to I to the second. And I to the second, for every two things you have underneath, you can take one out. So I to the first is the square root of a negative 1, and I to the second is equal to a negative 1. And I'm going to keep going, and this is going to get kind of confusing, but you have to watch carefully. The square root of a negative 1 times the square root of a negative 1 times the square root of negative 1 is the same thing as I to the third power. But what is I to the third power? The same thing as I to the third power is, two of them make a negative 1, and one of them make I, so this makes a negative I. Okay, the next one is I to the fourth, and I'll tell you what I to the fourth equals. Two of them is right here, equals a negative 1, so two of these equal a negative 1. Another 2 equal a negative 1, so a negative 1 times a negative 1 is a positive 1. Okay, let's see what I to the fifth is going to equal. Two of them equal a negative 1. Two of them equal a negative 1. And I'm showing you right here, two of them equal a negative 1. And one of them, which is right here, equals just an I, which ends up equaling an I. Okay, so what's my point? My point is, what happened, it started being an I, then it was a negative 1, then it was a negative I, then it was 1, and now do you see on I to the fifth it's repeating? It's starting with I again, and I bet I to the sixth is equal to a negative 1, and so on. So it repeats after every 4. So it can only be an I, a negative 1, a negative I, an I. So this is what older kids have memorized for imaginary numbers. I to the first is equal to I to the second is equal to a negative 1, I to the third is equal to a negative I, and I to the fourth is equal to 1. And here's the little cheer that they learned. I won with the negatives in the middle. So if you remember this, you will do well. So now, we're going to go higher now. I'm going to ask you to find, before I do I to the 124th or I to the 1035th or I to the 102, I want to do I to the 17th power. So, how would I do I to the 17th? So let's look up here. It's got to be one of these 4 answers, right? I to the 17th. And you know it repeats after every 4. So I can just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17th. I counted 17th, which is equal to I. Okay. Do you want to count 124 times going down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't want to do that. So this is how I'd like you to do I to the 124th power. So, this is what I want you to do. You know that this chart, there's 4 of them. This is the first one out of 4. This is the second one out of 4. This is the third one out of 4. And this one's the fourth one out of 4. So that's what you have to remember. So how did I do I to the 17th without counting? So this is what I want you to do. You're going to take your calculator out and take 17 and divide it by 4, because it can only be 4 answers. So everybody take 17 and divide it by 4. And you're going to get 4.25. What that means is I went through that chart 4 full times. I went through that chart 4 full times, but I went through 0.25 is the same thing as 1/4. I went through 1/4 of the way. I went four full times and only 1/4 of the way through. And 1/4 of the way through is I. So that's how we're gonna do it. So here we go. Everybody take 4 and divide it into 124. And that makes exactly 31 times. I went through it 31 times. 1/4 is 0.25. 2/4 is a half, or 50 halfway through. 3/4 is 0.75. This is 0.75 of the way down. This is a half of the way down. And this is 0.25. If you get no remainder like 31, the answer must be 1 because you're not 3/4, there is no remainder. So let's do 1035 divided by 4. I went through that 258 times with the remainder of 0.75. So I went through a whole 258 through that whole thing, but I went 0.75, so my answer is a negative I for this problem. And 102. 25.5, so my answer to I to the 102, I went 0.5 of the way down, and 0.5 of the way down is a negative 1. So that's how you do powers. Okay, now we're going to learn how to multiply. We're going to learn how to add, subtract, and multiply. So let's start with this one first. A negative 3i times 2i is a negative 6i squared. A negative 3i times 2i is a negative 6i squared, but you're not done. I to the second, I to the third, I to the fourth. I1 with the negatives in the middle. You're going to have to know this chart for the ACTs. You're going to change what I squared is by looking over at this chart that you need to memorize. And I squared is the same thing as a negative 1. You're going to leave the negative 6 and negative 6. You're going to replace the I squared with the negative 1. A negative 6 times a negative 1 is a positive 6. So that's your final answer. A negative 5i times 4i times 2i is a negative 40i cubed. Well, negative 40 stays the same. You're going to look at your chart and look to see what I to the third stands for, and I to the third stands for a negative I, so your final answer is 40i by looking at your chart. The next one says the square root of a negative root. Remember, the negative sign comes out and it turns into a negative, so now we have a negative root 6, and here we have a negative, take the I out, 15, which makes I times I is I squared times the square root of 15 times 6, which is 90. And if you look over at I squared is the same thing as a negative 1, so I can switch my I squared. This is made up of 9 times 10, which is made up of 3, 3, and 2, and 5. So the 3 can come out, so 3 times a negative 1 is a negative 3 root. 10 is left on the inside. So we're learning how to do negative roots. So let's do another one. How do you do a negative root again? The negative sign comes out and turns into the letter I, square root of 12, times the negative comes out and turns into I, root 2. This equals I squared root 24. My chart says that I squared is a negative 1, and 24 is made up of 4 times 6, which is 2, 2, 2, and 3. The 2 can come out to join the negative 1, which ends up being a negative 2 root 6. Final answer. Okay, the next part, we're gonna learn how to add and subtract complex numbers. So when you add two complex numbers together, a complex number is usually written as A plus BI. This is called the real part, and this part is called the imaginary part. So all you're gonna do is put the 3 and the 2 together. That's the real numbers. 3 plus 2 is 5. And then you're gonna put the imaginary ones together. These are the imaginary parts of a complex number. 5i take away 4i is 1i. Final answer. Putting like terms together. Again, this is the real part, and these are the imaginary parts. And the real part is 7 take away 8, which is a negative 1, and a negative 3i minus 2i is a negative 5i. Final answer. That's how you add and subtract complex numbers. Now we're going to do the distributive property. 3i times 2 is 6i. 3i times 5i is 15i to the second. I to the first, I to the second, I to the third, and I to the fourth. I1 with the negatives in the middle. I can look over at my chart to show me that I squared is the same thing as a negative 1, which ends up making this a negative 15. So it's a negative 15 plus 6i. Final answer. You usually write the real part and then the imaginary part second. Okay, let's keep going. Let's do this one. Um, 4 plus 3i and 2 minus 5i. 4 times 2 is 8. Outside term gives me a negative 20i. Inside term gives me a positive 6i. And the last two terms is a negative 15i squared. I squared is equal to a negative 1. So a negative 1 times a negative 15 ends up being a positive 15. So a positive 15 and a positive 8 makes 23 minus 14i, because I can put these two together like terms. Okay, last part of the assignment is how do you divide complex numbers. So I think we have 2 of these, and I think we are done. There's a rule in math that says you can never have 0 in the denominator in math. You can't have a radical in the denominator. You also can't leave an I in the denominator. These are all no-nos in math. You can't have a 0, you can't leave a radical, and you can't leave an I. So this cannot be the final answer because there's an I. To get rid of the I, you need to multiply the top and the bottom by. This is something you've never done before, but all you do is you change the sign to 3 minus 6i. Whatever you do to the bottom, you have to do to the top. So if you don't know what to multiply the top by and the bottom by, you have to multiply it by the same thing. All you do is you change the sign from a positive to a negative. Okay, now let's go through it. 2i times 3 is 6i. 2i times a negative 6i is a negative 12i squared for the top. I'll simplify it later. 3 times 3 is 9. 3 times a negative 6i is a negative 18i, a positive 18i, and a negative 36i squared, which makes I squared, remember, equals a negative 1, so a negative 1 and a negative 12 equals a positive 12 plus 6i for the top. The bottom, the 18i's and that positive 18i cancels out. remember that this makes a negative 1. A negative 1 times a negative 36 is equal to a positive 36. A positive 36 and 9 is 45. Let's do one more so that you remember how to divide. I'm going to rewrite it. 2 plus I divided by 1 minus I. There's a rule in math that you can never leave the imaginary in the denominator. So I need to multiply the top and the bottom by exactly what this is down here, except you change the sign in the middle to a positive. So don't forget to change the sign. I'm going to end up doing the FOIL method twice in this problem. So here I go. 2 times 1, 2. Outside term, 2i. Inside term, I. Last two terms, I times I is a positive I squared. Divided by 1 times 1, 1. 1 times I, positive I. 1 times a negative I, negative I. And a negative, right here is a negative I squared. Okay, we simplify this. Remember, I squared equals a negative 1. I can put the 2 and the negative 1 together to make a positive 1. And 2i and 1i gives me 3i. On the bottom, the I and the negative I cancel each other out. Remember that this makes a negative 1, so a negative of a negative 1 equals a positive 1, and a positive 1 and a positive 1 makes a positive 2. As you can see, I got rid of the imaginary part in the denominator. Now it's 2, and you can have 2. In this problem, I have 45, and as long as they all have something in common with each other, the 12 and the 6 and the 45 all have a 3 in common. 3 goes into 12 4 times, 3 goes into 6 2 times, and 3 goes into 45 15. You could simplify it, but that's how you divide imaginary numbers. Okay, these are all the notes for, but I'm giving you a couple of days to do this worksheet, so.